pump storage and the way it's been used as renewables has come online has changed greatly, but it's saving the power grid every day.
Welcome to the Stantec.io podcast, where I speak to our scientists, designers, engineers and architects who are combining subject matter expertise with cutting-edge technology to develop solutions that can help solve the problems of today and tomorrow. My name is Dave Roberts.
And I'm Mike Arsenault. We've covered the energy transition previously on this podcast, but this episode will cover the storage of renewable energy, which can be a massive challenge. Specifically, we're going to discuss pumped storage hydropower. Joining us to talk about this very important tool in the Renewable Energy Toolkit is Don Erpenbeck, Stantec's Global Sector Leader for Dams and Hydropower, and Craig Scott, Stantec's UK Director of Waterpower and Dams.
Don is based in Wisconsin in the United States, and Craig joins us from Edinburgh in Scotland. Welcome to the podcast.
Don, I'd like to start with you. You've had an extensive multi-decade career in the hydropower industry. Where are we in the energy transition now compared to when you first began your career?
Oh, well, when I first began my career in the United States, anyway, in North America, we were building our very last utility grade pump storage project that's been built. I mean, there's 24,000 megawatts of pump storage hydropower in just the US alone. It's the third biggest fleet. So we were just starting construction of our last one. And the early construction was tied to building out of the original nuclear fleet. And then what's happened is the pump storage and the way it's been used as renewables has come online has changed greatly, but it's saving the power grid every day from regular failures. And then as we put more renewables online, the way it's being used, it's gone from pumping at night to pumping in the day because of excess solar. And so we've kind of used up the capacity we had of pump storage. We're kind of starting to hit the limit of how much solar the system can absorb, but it's kind of been forgotten that the pump storage fleet has been in the background firming up the renewables as it transitioned from a nuclear and coal-based fleet to more of gas turbines and then solar and wind. And so the way pump storage has operated has completely transitioned from nighttime pumping to daytime pumping. And we're just running out of how much we can do with the existing fleet. And so a series of new projects, almost 10,000 megawatts, are almost shovel ready and in the contracting stage in the US alone. So that's the US side. Globally, it haven't really changed that much. Some pump storage continued to be built in key locations, but in the developed markets, it's been similar. But China's been putting on 4,000 megawatts, 5,000 megawatts of pump storage every year for the last 15 years, and it's now the largest fleet in the world.
So Craig, globally we can produce a lot of renewable energy, but what do we do with all of it once it's produced? What are the storage challenges facing the energy transition?
Well, I think globally, certainly when it comes to the developed economies, many are on a very similar trajectory. I hail from New Zealand, but I live in Scotland in the UK these days, and we went on a journey very similar to the US in both those countries. Here in the UK, what is happening is an extensive transition from what is essentially a thermal-based electricity grid to a renewable-based grid. So the UK, for example, 2 months ago shut down its last coal power station. And if you think, given the UK's history with the Industrial Revolution from the 1700s to the 1800s, 1900s, which was very thermal-based, to actually have closed its last coal power station is a massive achievement. But coupled with that has been a huge expansion, particularly here, of wind power. And for us, it's the intermittency of the wind power, where for offshore wind farm, if the wind's blowing at times that you don't want to use the electricity, then you're essentially giving away free electricity. And so for an optimized grid to make the system work very well, you simply want to store that electricity. And just as Don said, the history has told us, and the history of grid scale electricity storage has actually been pumped hydro throughout the world. And so here in the UK, there's a significant development pipeline of pumped storage hydropower, and similarly in many countries of the world throughout the Middle East, the Australasias, Asia, and what Don was talking about in the United States. So it's a very big market at the moment.
Don, let's keep the conversation going about pump storage, hydropower, and let's get into the specifics. So what is it, and why can it be a catalyst for our energy storage issues?
Well, pump storage is essentially a giant water battery where we build a lake on the upper top of a mountain and we pump water up and hold it up there. And when there's excess electricity, we go into pumping mode. And then we go into generating mode when there's a shortage of power and we drain that upper lake to a lower lake. So it's essentially a water battery, but it's exceptionally efficient at over 90% efficiency for one trip up or down, which makes it about 81, 82%, what we call cycle efficiency. But in addition, what pump storage has over battery storage is that it is a synchronous machine and has inertia. And the inertia is exceptionally valued. Essentially, batteries and photovoltaic power, and as well as some wind power, are asynchronous. So they're not actually synchronous power. So the quality of the power that comes out of those in terms of the quality of the sine wave is not very good. And it's not able to travel very far. And so you need inertia in the system in order to do that. So pump storage plays the additional role that batteries can't do of sort of anchoring the grid from transients and lightning strikes or anything that can happen in the system to be able to ride through any faults or transients or spikes that occur and sort of clean up the quality of the power. It's like a giant power quality conditioning system that batteries and no other form of power can do except hydropower. Conventional hydropower can do the same thing. And so this is why there's a lot of interest, because of all the inverter-based and, basically photovoltaic is DC, so it needs an inverter to convert it to AC power. But we're running synchronous, and they're always synchronous. So it plays a very complicated role in the power grid that we struggle with the value of, but the control rooms and the control centers know that for reliability of the power grid and for emergency power, it is the key piece, is having inertia in the system. So this is what pump storage does, because they are massive machines, sometimes weighing, 800, 900 tons of rotating inertia.
Yeah, Don, I'd probably add to that the other thing to think about with pumped storage hydro is its long duration. One of the things that people forget or are not so aware of when it comes to battery systems, which are very common from the Tesla batteries through to these big battery parks that have been installed, is that they are, compared to pumped storage, very short duration. And so particularly here in the UK, the regulatory focus and delivery of the projects is very much going to be based around long duration, where these plants can store massive amounts of energy but actually dispatch them from 10 hours to 12 hours, and in some case 24 hours, where at full power they'll be putting out that energy for a long duration. And so I think, in addition to just simply the quantity of energy they can store, they can actually give it back to the grid over long durations of time.
Craig, I would add one thing too, is that a pump storage hydropower has no degradation over time. So over 100 years, there's really no degradation, unlike most battery plants, which degrade, and the batteries and the systems are like your iPhone battery, that they begin to get shorter and shorter the more they're discharged and used. Pump storage has none of that, because we don't rely on any chemicals in storage. It's just, water level and number of cubic meters of water pumped, essentially. And that's your storage. So that's the other big benefit it has, is zero degradation. So its long lifetime is very valuable if you're thinking long-term and sustainability-wise.
And Craig, how does digital technology play a role in the creation and maintenance of pump storage facilities?
It's playing a role in every aspect of our lives and the projects these days. These projects are very multidisciplined. They're very much large civil engineering structures. They have tunnels, big underground caverns, big pipelines. They have numerous amounts of mechanical engineering components to them, the turbines, the gates, the valves, the pipelines, and then there's the electrical componentry. And these days, to make delivery of projects efficient, you need digital technology, BIM, you need good systems for storing data, project information, correspondence between owners and contractors. And to actually deliver a project on time, or not on time, but actually quicker than may have been done in the past, you have to integrate the project with modern digital tools. And underpinning our support of our clients and delivery of these projects is essentially a whole digital architecture to make these projects work and make our services to clients and the projects work well. So it is almost, well, it is the norm nowadays, but it is to get these very complex projects delivered efficiently, you need to be able to visualize them in 3D and get everybody from contractors to owners to consultants like ourselves to be able to see a project and make sure that a component fits in a certain space and that you haven't missed something. So just as a simple example, but it really is core to the industry, and many younger people joining our industry are coming very highly skilled in digital skills. So it's everything nowadays.
You mentioned a multidisciplinary approach, and that kind of leads me to my next question. So, Don, what is the collaboration process like between different groups at Stantec to get a pump storage project to fruition?
Oh, that's a great question. It's one of the things that I tell our clients is that these are not civil works projects. They're actually massive integration projects, and everything has to work together from the geotechnical to the electrical. And that sounds crazy for the geotechnical to matter to the electrical, but it actually matters a lot. And the hydraulics in the middle, the civil structurals, and it all is a massive system. And everything is interconnected in these plants that you cannot isolate one discipline from another discipline, and they all need to be involved in the initial planning phases. But it does kind of go through phases, the project, once you kind of get the early design done. It's very geotechnical heavy and civil heavy early on, and then the back half is a little bit more electrical and mechanical. But the fundamental layout and the fundamental way the whole plant will work is an integrated electromechanical, civil, geotechnical system. And it requires all of us to understand each other and to work together and understand the issues of the other disciplines when we're trying to make decisions. Because many of these plants are underground, with big, large underground caverns. Some of the largest caverns in the world are on pump storage projects. And this is where we put the equipment in a large underground space. So you can imagine the selection of the equipment and the location of the cavern and the quality of the rock all begins to matter. And then they're massive machines. We've got to bring them in and out of tunnels and bring the equipment in and out. So there's even a tie to the access roads, which are huge pieces of some of these jobs, depending on how remote the location is, as well as figure out how to get the power out of the mountain and get the electricity out and get it out to the transmission grid and get it connected in a way that is very environmentally friendly. One of the projects Craig's working on has a long tunnel to get just the transmission line out of the ground and get it out of a park area so that they never see the transmission lines.
So definitely a massive undertaking. So Craig, I'm curious, what are some of the challenges or perhaps limitations of pump storage hydropower?
At a larger scale, probably the first challenge is actually getting people to actually visualize, certainly at a larger scale pump storage scheme, how big the infrastructure is. Now, Don talked about the size of these caverns. The one we're working on here in Scotland, there's 3 caverns to make up the power complex, but one of the caverns is the size of a cathedral. And if you've seen some of these big cathedrals around the world, they're fairly impressive structures, and that's just the size of one of the caverns. So firstly, it's probably getting people just simply to appreciate the size of the infrastructure. The tunnel on this particular project, for example, the waterway tunnel, is 10 meters diameter. You can fit 2 double-decker buses on top of each other and still be able to drive through the tunnel. It's huge infrastructure, and the generation equipment is 50 meters high, for example. So it's just understanding the size and the dynamics of this infrastructure. But ultimately, there is a number of challenges. It's an electricity generation facility that's got to fit within a regulatory environment, electricity trading market, and it's because the whole market for electricity is a complex network of different generation forms. And in the UK, it could be nuclear, it could be wind, could be tidal, could be hydropower, and then pump storage for batteries coupled with lithium batteries for battery storage. Making that the electricity system work from a grid operator's point of view is very complex. And so the pump storage schemes are one part of the generation mix and one part of the overall system integration to transition from a thermal-based grid all the way through to a renewable-based grid that's happening here in the UK. So we're working within a very dynamic environment that is influenced by trading markets, influenced by regulatory legal structures, but it's actually a really enjoyable industry to be involved with. So they do take time to develop these projects as well. The one we've been working on now has been going for many, many years to get to the point of financial close to where the project can be developed. But ultimately, pump storage is one key part of the jigsaw puzzle to actually make a good electricity network work within the sort of renewable and the transition environment that we're living with.
Don, I'm interested. What's a global pump storage project that you've worked on that you're particularly proud of, and why?
Oh, I'm proud of them all. And I've spent a lot of my career repowering and sort of refurbishing the older fleet. But I would say, that's a hard question. I would say internationally, I mean, the big one I worked on in my career, which is Rocky Mountain when I was young, which was the last one built in the US. And I worked on it for the first 5 years of my career. But I subsequently have worked with the power plant for the last 25 years in keeping it running and solving problems. And we actually upgraded the plant. So that project, I tell the client, that's my plant. That's not his, it's mine, because I feel like I've lived every minute of it. I know every nook and cranny of it. So that one I have to say I'm the most proud of. But honestly, there's so many of them. I'm working in Wales. In the UK, we've been working for years on refurbishment of a big project there. And there's some projects in the Philippines that we built, which in an islanded environment, the pump storage projects are even more important, like the UK, Australia, Japan. So in this islands, they tend to be very, very important assets. So the project in the Philippines called Kalayaan is another one that I'm proud of. Craig's been working on a couple in Israel over the last, 10 years that are also very interesting. But I'm proud of them all. I mean, they're all, you go to these things, they're parks. They're people don't know they're power plants. They think they're parks. There's hiking trails and biking trails and campgrounds. They're beautiful facilities overall. They have vertical drop, usually a lot of trees or cliffs and rocks, and so really nice hiking. So I'm very proud of the way that they are so sustainable and fit into the environment around them when I go to any of them. So I'm proud of them all. I can't really pick one, but if I had to, it's the one I've been working on my whole career, which is Rocky Mountains.
And Craig, along the same lines, what project in the UK has demanded a lot from you and your team?
We've been involved in several projects in the UK. Don mentioned the projects in Wales to Norwich, but the two in Scotland that have drawn a lot of our attention have been the Cruachan 2 for Drax and the Corrie Glass project for SSE. These projects, we are consultants and we support clients and deliver these projects. They're the ones who often come up with the genesis of the idea, and then they ask us for support, and we provide the technical support to deliver the concept designs. And in the case of the Corrie Glass, we supported planning and the environmental aspects of the permitting and getting the licenses to actually develop the scheme, which SSE successfully achieved after many years of planning and community consultation and social and environmental studies. But ultimately, we supply quite a variety of services to SSE for this project, and we live and breathe these projects with the clients. And they, as engineers, we tend to love what we do, and so it's been quite a pleasure to be able to work on this as part of this energy transition in the UK using these Scottish-based projects. To be honest, be a real honour, and I'm hoping that my career sees out the development of the Corrie Glass and some of the other ones in Scotland.
Don, last question to you. Where do you think pump storage is going the next 5 to 10 years? And maybe if you can share what you think might be the next big thing in the industry.
Well, where pump storage is going in the next 5 to 10 years is a lot of the projects that have been in planning are going to be heading to construction. There's 30 to 50 in planning that are also real behind it. But these first ones, it's been a long time since we've built any outside of mainland Europe in a while. And that's where we're going to be shifting our focus, is to much away from planning and into actual building. So it's going to be an interesting challenge to change and shift our focus and the skill sets of our teams to go from engineering to constructions level type of design and support, which are very different things. But the planning is going to continue. Power grid operators have realized that these are very valuable, and they're viewed almost now, historically they've been viewed as a generating plant. They're no longer viewed that way. They were viewed that way just because historically there wasn't anything else to compare them to. They were storage, right? Now there's batteries, so now their storage has its own class. So this is what's the big thing that's been changing, is the focus on the transmission grid and all the other things that pump storage can do. So the valuation on these plants is actually one of the hardest things to do, because they do so many things for the grid, but you don't actually get paid for them, but the grid needs them. And the control system and the transmission grid operators have realized how valuable they are. And so I believe there's going to be a lot more focus to the power of the quality and the inertia and the other what we call the ancillary services that pump storage can do, because they're also synchronous condensers. They just can do so many things, and they're so flexible. They can operate in 20 different ways and multiple different power settings. So they're super flexible. So I think there's going to be more of a focus on valuing these softer benefits that the grid needs but doesn't know how to pay for, particularly in a deregulated world. So I think there's going to be some rearrangements on that. I mean, I think the UK is a little bit ahead of the curve with something they call cap and floor policy that'll be issued shortly.
And that brings us to the end of today's episode. It's been fascinating discussing pump storage solutions with both of you today and the exciting advances that technology is enabling in this space. Don and Craig, thank you once again for being part of the Stantec.io podcast.
Yeah, I just want to thank everyone for listening, and I encourage everyone to go online and look at the options and instructional information if you want to learn more, including Bill Gates Foundation has done something, What You Don't Know About Pump Storage. That's an interesting video of a project in Ireland.
Also, thank you from me as well. And I'd encourage anybody listening to this podcast to pay attention, because the skills and resources needed to deliver this global transition of energy storage is significant. And there's a large future ahead for people in this industry. And anybody with an interest in hydropower, pump storage, civil, mechanical, electrical engineering, to contact us and play a part, because the globe is going to need a lot of human resource to actually deliver all this infrastructure that Don mentioned, 30 to 50 around the world. So that's a lot of money and a lot of projects. Thank you.
And thank you for listening. Future episodes will continue to explore how digital technology is shaping our world. In the meantime, you can also visit our website at www.stantec.io for more information.